Children, welcome to this class on calculus. So to learn calculus, primarily important thing to learn is learning about the limits. Limits is one of the basic fundamental units. We are learning calculus. So let us primarily go and find out what exactly the limit means, and then we will do some illustrations such that you would understand limits. Okay, so to understand limits, let us assume a small body is falling from a top cliff. So whenever it is falling down from the top of the cliff, actually it is at a stationary place at the top of it, and then as it comes down it picks up the velocity, and then it would be at a maximum velocity when it hits the ground. So velocity won't be constant. Velocity would be it would keep on changing time again and again. Suppose if we plot a graph like this, taking time on x-axis and taking the length from the top of the cliff. So at the beginning of 0 seconds, 1 seconds, 2, 3, 4, 5 seconds, and this is some 10 meters, 20, 30, 40, 50 of length from the top of the cliff. So it would be at a 0 distance at the beginning, and then as it falls down, it picks up the velocity and the length covered will be much higher. It covers more length within a short span of time at the end of its journey. Suppose if we have to find out a velocity of this falling object at 3 seconds, here we need to take a small part of length. That length should be divided by this small part of time. That would give the velocity. We need to understand how much small this time interval or how much small this distance interval should be. So we can make it as small as possible. So the limit should go up to 3. So that interval is known as, that smallest interval is known as limit. So once we go and understand, take some examples and all, then we will know thoroughly. So most of the times we apply these limits to understand in calculus. Suppose there is a function by name f of x, and then this f of x, suppose this f of x is defined as x plus 2. So for every value of x, how this function f of x behaves. Let us draw the graph and observe it. So on x-axis, so we take x values. This is on the positive side, this is on the negative side, and this is f of x. 1, 2 positive values on the y-axis and negative values the y-axis downwards. So whenever x is 0, the value of f of x would be 2. For 1, it would be 3. For minus 1, it should be 1. For minus 2, so the graph goes like this. Suppose if you wish to find out what value f of x approaches when x is nearing the limit 1. So that we are going to find out. So this is 1 on x-axis, this is the value of x. You can approach this from the left hand side, from this side, or you can approach this from the right hand side. So when we approach this from the left hand side, we call it as x, we are approaching 1 minus. If we approach from the right hand side, then we say this is right handed limit 1 plus. Plus we put at the exponential place. If you put minus at the exponential place, that means we are approaching the limit from the left hand side. That means we are not taking the value 1, but we are taking, suppose if we are approaching from the left hand side, we are taking the value 0.9 or 0.99, or we are taking 0.999. So imagine, suppose if we take a value of 0.9, the value of f of x would be 2.9. For value of 0.99, the value of f of x would be 2.99. For 0.999, the value of f of x would be 2.999. So when we observe these values, it is slowly approaching towards 3. So that is the left hand sided limit of this function f of x. Suppose if we are approaching from this right hand side, we are approaching. So this should be 2.1. So 2.1, that should be 1.1. 1.1, that should be 3.1. Suppose if we take a lesser value nearer to 1, 1.01, that should be 3.01. 1.001, that should be 3.001. So here also it is approaching 3, and here also it is approaching 3. So right hand sided limit is also 3 here. So through both of these things put together, the limit of this function would yield value 3. This won't be that much simple. If we take another example, then we would understand. I'll get you through another example. Okay. Suppose we are doing this function f of x. F of x is equal to x minus 1 by x minus 1. So it's pretty simple. X minus 1 by x minus 1, both of them can get cancelled together, and it can give a result of 1. Suppose x value is 1. Actually what we are saying is true. For every value we get 1, but there is a special case where x is 0. So replace 0, x with 0, 0 minus 1, or not 0, but let us replace x is equal to 1. 1 minus 1, 1 minus 1. So 1 minus 1 would be 0, and 1 minus 1 would be 0 in the denominator too. 0 by 0 would give us a indeterminate form. This would give an indeterminate form. That means there is no value for it. Let us plot this thing on the graph. This is the x-axis. So at x is equal to 1, we can't define. So we are placing a sign there. For all other values, it would be 1. So this is how the graph looks like. Suppose if we take this limit where x is approaching 1, from the left hand side, if we observe, if we take 1 as a value, it won't get defined. So there is we can't define a function at 1 of the x value. Suppose if we are approaching this from the left hand side and approaching from the right hand side, we can clearly observe as the value reaches 1, the limit is 1. So for the both sides, for the left hand side and for the right hand side, the limit is 1. So the value may not exist at 1. At 1, the function cannot be defined, but limit exists there. Limit of this function would be 1 again. Let us take another example such that we understand it clearly. So this time we take a value of f of x is equal to 2 if x is less than or equal to 0, is 1 if x is greater than 0. This is the function. Suppose we are plotting it on the graph. So this is the x-axis and this is the y-axis. 0, 1, 2, 3, 4, minus 1, minus 2, minus 3, 1, 2, 3, minus 1, minus 2. For every value of x greater than 0, the value of y f of x is 2. So the graph goes like this. For every value of x less than 0, so we will change the symbols here. Less than 0, the value is 1. Here it is not defined and it goes like this. Suppose if we are approaching this from the left hand side, limit of f of x as x tends to 0, here the limit from the left hand side is approaching the value of, it is not exactly 1 but it is approaching a value of, so left hand sided limit is 1. And if we approach it from the right hand side, the value is approaching 2. So from the left hand side the limit is 1, from the right hand side the limit is 2. So when the left hand sided limit and the right hand sided limit both are different, there exists no limit for this function. So there is no limit for this function, and you can also see there is no continuity here. The graph is broken. Regarding continuity we can come across in another video lecture, but this is the thing. Let us draw two more graphs. Such that we understand these limits, and then we will close this video and then we will try to solve some more problems as we move forward in the next video. Suppose f of x is equal to mod value of x. Find out as x tends to limit as x tends to 3. So for every value of x, whether it is minus 1, minus 2 or minus 3, the graph would be like this. We need to find out at 3. From the left hand side, from the right hand side, we would approach the value of same 3. So the limit is 3. Okay. Now let us do one more example. Like f of x is equal to x square. We need to find out as x approaches 2. So the graph would be a parabola because it's a square value. So this goes up like this, 2, 4, like this. As it approaches 2 means the value would be somewhere 4 here. Even from the left hand side, from the right hand side, for both the limits the value approaches 4. So the limit as x approaches 2 would be 4 for this function. Hope I am clear how to find out these limits. So in this video lecture we learnt about what is a limit. Let me tell you, these things are useful whenever a big storage tank is getting emptied, or in taking out derivatives in the stock market, or in the propulsion of the rockets. In all those places this calculus and this application of limits would be useful. In the next video we will try to learn regarding finding out limits for some more functions, along with the finding out limits for special functions. Thank you.